right, this is your review for your exam. Let's see what you've learned so far on this wonderful COVID situation. All right, so number one, and if these don't sound familiar, maybe you didn't watch the videos, need to go back and look at some of the videos that you missed. Everything's still there. Also, they're on, if you look up Papizan geometry, there's a playlist on YouTube, 2020 playlist, that has all my videos listed. So, no excuse for not knowing the stuff. Alright, will P be parallel to Q? Now this is a special situation. Why would P be parallel to Q? This is going back to the proof kind of things, and this is just one proof. Now, when we look at these two angles, we can think about where this position is. These are alternate interior, but it's alternate interiors are congruent when they're parallel. But does it say they're parallel? I'm asking you, why are they parallel? So instead of the regular alternate interior, it's going to be the alternate interior converse rule. Where normally I say I got parallels, so that means all my angles will be equal. Well, now we're flipping around. I've already got equal angles, and so now that's leading me to say I've got parallels. So that's switching it around. That's just the converse of the rule. Anytime you're asked about why do I have parallels, it'll have to be a converse rule, because there's not like definition of parallel and things like that. It's all about the reverse of these particular angles. The angles for parallels are corresponding, alternate interior, alternate exterior, and then same side, or the consecutive. Remember they had two names. Consecutive was the other. So if it's not 1, 2, or 3, then you're probably not thinking about the right thing, because parallels have to deal with those three types of angles. But if I'm asking why do I have parallels, then it's got to be a converse rule. If I said why do the angles equal, then that would be the type of angle, whatever type it was. But I didn't ask about the angles, I asked about why do I have parallels. Okay, this was a special part that we didn't get to go over in class, but it was on the notes for special parts of triangles. And I think I took this one out. If not, I'm going to. So let's skip that one. I'll have to go back and look. I think I am taking it out. Bisected. Yeah, that's not on there. That's not on there. I had to replace that with something else. So when you see that one, if that one's still on the study guide, it's not on there because we hadn't gotten to that part yet. All right, so let's go on to number 3. What type of triangle is this? It's an isosceles. I see two matching legs, leg, leg. So that makes this the base. So remember, base angles match. So whatever x is, z is going to match it. So I can put x and x. They're going to be matching. And then triangles, main thing about triangles, they make 180. I got 70 showing. That leaves me 110, but 110's got to be split between the two. So when I split that, I'm going to get 55. Okay, so next, which angle is the largest on the triangle? Either A, B, or C, or maybe they're all the same. Well, they're not all the same, of course. So the biggest angle is crossing the biggest side. I'm looking for the biggest. So the biggest side is 12. What angle is opposite to that? A. So A would be your answer. Can a triangle be formed out of the segments? Now, a lot of y'all missed this one on that last test. You think about the biggest one, 40, pick it out. The other two, 15 and 30, have to add up to be more than the 40. The ones you add up have to be more than. So are they 35? That'd be 45? Yes, that is more. So yes, it will make a triangle. Okay, go back and watch the things. Now, we didn't talk about this one in class, but I'm going to go into it in a little more detail. When you have a median drawn, it goes from the corner to the edge to the middle of one side. So the side, of course, if this was 20, it'd be split in half, midpoint, halfway, 10 and 10. So that's an easy one for WE on number 7 right there. If WE is this, then that's just going to be 12 because the whole thing's 24. But what we didn't get a chance to talk about was what happens when other medians crisscross it at that point in the center. It's called the centroid. And if you go back and watch that video, it'll show that. Another line crossing through here hits it at that point called the centroid. Now that point is important because it cuts that median itself into 2 pieces. Now they're not equal. There's going to be a short piece that is half the size of the long piece. The long piece goes into the corner and the short piece just hits the side. So if this short piece was 5, the long piece would be 10. Or if the long piece was 20, the short one would be 10. It's half the size. The short one is half the size of the long. So what I'm giving you on this drawing right here is the short piece. See that 4 right there? So if the short piece is 4, what's the long? 8. That's all I'm asking you to do. That simple little thing. So you decide. If it goes into the corner, that's the long. If it's hitting the side, it's the short. And you can kind of tell which one's which. So here's an extra one. If this was 18, what would YF measure? YF would be the short, so it'd be half the size. It'd be 9. There you go. Okay, not so bad. All right, so this I want you to set up the trig function, and this is what we've been doing the past week in class. So it's just setting it up. You're not going to use the calculator. You're just going to show me the formula, and it'll be multiple choice. So you just have to like pick out the right one. So let's label it like we did in class. This is the hypotenuse, of course, and then here's my special theta angle. So this would be the opposite, but I don't have that. So 14 has to be the adjacent. So I got adjacent and hypotenuse. That means it's going to be a cosine formula. And if you don't know your formulas, you better be going back and watching the video on that. So cosine of 42 equals, remember the angle has to go with it, the formula adjacent over hypotenuse. So it'll be 14 over x. Now that's set up, but it's not found x. I want to get x. So that means I got to do my math on it and get it by itself. I'm going to put this group, cosine of 42, over 1. You remember, yeah. Cross multiply. 1 times 14 is 14. X times the group is just x times the group. Cosine of 42, right? Is x by itself? No, we still got to keep working. If x was by itself, you'd be done. X is not by itself, so I got to say, hey, that's multiplying. How do I get rid of multiplying? Divide out cosine of 42. It's a group. The whole thing is going to cancel. Put it on the other side too, cosine of 42. So what's left over? Let me clean some of this off here. What will be left over is now x is by itself, x. So x is left by itself, and I've got 14 over cosine of 42. Now normally this is where you put the calculator, but this is where we're stopping. So that's what your answer will look like. You'll have multiple choices, and one of them will look just like that. All right. The other ones might have multiplying. They might have sine or cosine or tangent and something different. So we'll do it that way. All right, so next, we got some of these from that test before where you're supposed to match it to the name. I think this is kind of what I used to replace a couple problems that we hadn't gotten to yet. So like that number 2, this is going to replace that. All right, so what is this thing? This is a plane. It's plane, and how do you name a plane? With 3 points. So E will not work because it doesn't have 3 points. And I think if you scroll down, mine's going to mess up if I try to scroll ahead. It's going to be plane ABC, or it could be called CBA. Doesn't matter the order, just has to have all 3 letters and not just 2. So it can't be that one. Okay? All right, so number 2, what do we see? Well, if I got matching hatch marks, that's a little bit more than just a segment. That's equal pieces. So I would say AB is congruent to BC. That could be one of the statements about it. Or it could be just the midpoint being described. I can't remember which one exact it is, but both of those would work. So either one, I won't have both of them on the test. It'll just be like one quick one. All right, number 3, this is just identifying the stuff. This just with one arrow, remember that is a ray. Now to name a ray, the arrow has to point to the right because that's the way you read the letters. When you read stuff, you go left to right, so it's going to go that way. Where does this ray actually start? Well, the arrow means it keeps on going, so it's starting on A. So A has to be first, so it could be called ray AB, or it could be called ray AC. It could be ray AB or ray AC, but it has to point to the right. Okay, so this would not work. AB would work right there, and I don't know what's the other choices. I can't scroll down. Not yet. All right. Then, when I do scroll, we've got some more choices. Number 4, that's just a segment. You could call it segment AB with a straight little bar, no arrows, or BA. Does not matter the order. The ray is the one that has to be in the right order. All right, number 5, you've got a right angle right there. When you got 2 lines that cross like that at a right angle, that is called perpendicular, and that's how that'll look. That's that symbol. Remember that? Okay. Doesn't have to be just drawn like that. It could be drawn like this, A, B, C, D, like that, and there's your right angle. Those are perpendicular as well. So you could have just a T, you could have an upside down T, right side, sideways T, or you could have the whole Jesus cross going there. All right, and then number 6, you've got parallels. So see the little white hatch marks on there? So that's parallels, and that's your symbols, parallel lines. All right, on this next one, you're trying to classify it, and when you classify it, you're deciding, do any of the sides match? That would make it equilateral or isosceles, or if nothing matches, it's scalene. And then what are the size of the angles, like acute or obtuse or right, or if all of them match, it'd be equilateral. You can't tell by just looking at it. Remember back when we did Pythagorean theorem, we did some graphing, we had to do a lot of rise and run going across here. So that's what we're going to end up doing. And so we're going to do each little connection here, a rise and a run, and a rise and a run. And it doesn't matter about the sign right now, we're just doing the numbers. So like here, 1, 2, 3, 4, 5 going up, 1, 2, 3, 4, 5 going across. This has 1, 2, 3. This has, I think it's 7 going down, and then 2 here, and 1, 2, 3, 4. It's got to be 8. All right, so technically you're supposed to say 5 squared plus 5 squared, and 3 squared plus 7 squared. Each triangle, you're doing a little quick Pythagorean theorem for them. 8 squared plus 2 squared. And this makes 50, and you're going to take the square root, but don't worry about actually working it all the way out. 9 plus 49, that's going to make 58. I think that's right. And then 64 plus 2, that's 68. Do any of them match? Right there. You can stop right there. Do any of those sides match? No. So we know it's scalene because nothing's matching. All right. Then you can look at the size of the angle by setting up these 3 things into Pythagorean theorem. Now, since we didn't take the square root, and when you put it in Pythagorean theorem, you square it again, it's going to come out to this whole number. So like the biggest one, 68, this is on the bottom, I think of page 17, how to tell which one's which. Put that as your hypotenuse, 68, equal to the other 2 added up, 50 plus 58. So obviously it's not equal. If it would have been equal, it would have been a right triangle. Well, it ain't that, is it? If the legs are bigger, if this is on page 17 of your notes, if you took the notes on triangles when we did it that day, it tells you this is acute. When the legs are bigger, it is acute. So this is an acute scalene triangle. If the hypotenuse had been bigger, then you would have had an obtuse scalene triangle. That would have made it obtuse when the hypotenuse is bigger. So, one to go back and check if you haven't done it. Alright, then, roll this off. Alright, so, use the drawing with right, find these. Now, we have parallels, and we did a whole bunch of these before. We start with our basic set, vertical, complementary, and supplementary. I always look for those first. Verticals, I got it. Opposite, remember, that's what they are. 40 and 40, vertical, they match. Alright, and then I don't have any complementaries, right angle boxes, but I do have supplementaries. Sitting up against a straight line, these two will make 180, and these two will make 180. So, separately though, okay, 180 minus 40 gives me 140 right here next to it, and then I can go ahead and put the vertical, and I got everything in that group, it's all done, okay? Blow this up with your computer screen if you can't see it, make it bigger. And then the 120 from 180 gives you 60 for those two in that group. Okay? Now let me clean that up so it'll be a little nicer looking. Alright, so I got 120, I got 60, 60, 40, 140, and 140. So now, I got to get some numbers. All my answers are up here in this other group, so that's where it gets tricky. That's what it's about the jump from parallel to parallel. So here's a parallel and here's a parallel. Which way is it going to jump if I have to go from parallel to parallel? Is it going to jump sideways or is it going to jump up and down? It's going to jump up and down because the parallels are up and down. It has to jump this way. So everything in this group will eventually match everything up here, but some of it is going to be broken up. So what I suggested all the time is start with the small one. Just move the small parts out of this group. If this group jumps up here, the small 40s are going to end up right here, 40, and Q will be 40. Just move the small ones, not the big ones. All right? Then you go look at that other group. So we're through with this one. We're just going to clean it off, make it a little neater. All right, you don't have to erase yours. Now, the other group has the 120 and the 60, but I'm only going to move the 60s, the small ones. The 60s, look at where they are. Top right, going to be on the top right when it jumps up, and the bottom left be the bottom left. See, I've already got two of my angles that I need for my answers. So I just moved the smaller ones. Now, don't move the big ones at all. Forget about the big ones. You come up here now and look at that group. I got three angles sitting on top of this straight line. See that line right there? All three of these have to make the magic number 180. I already got 40. I already got 60. That's going to leave me 80 for the middle. So angle R would be 80. And if I wanted the vertical, I could do that too, 80. All right? Or if you got down here, you can see, hey, there's a little triangle. What do triangles add up to be? Hey, 180. That works there too. Okay? So if you get stuck, that's always a way out right there. All right, next, find the distance. We just did some of this a minute ago with the classifying. Rise and run. Do your rise and run to do your distance. And then do Pythagorean theorem. This is 3 spaces on the bottom. 1, 2, 3, 1, 2, 3, 4, 5 going up. So all I got to do to find that is say 5 squared plus 3 squared will give me my hypotenuse squared. 25 plus 9 makes 34. So square root of 34 is like 7 point something. No, it's not 7. It's 5 point something. So like 5.8 maybe. So you'll have to look that up. I'm not sure. All right, so that's your distance. How long would that side be? About 5.8 blocks long. Can't count it. You have to do the Pythagorean theorem. All right, then the slope, you're going to use that same rise and run for slope, but you need to stop at the very beginning and say, okay, slope's always positive or negative. Which way is that black line going? That black line is going down, isn't it? So that's a negative slope. And then put your numbers, your rise over your run. So it would be 5 over 3. And that's all you need right there. Okay? All right, 15. We're doing another trig problem here because I'm looking for an angle. And this is what we did this past week in class with trig. And this is when the angle's missing. It's a little easier, but you still set it up the same way. Now, I think my right angle got left off. But that's the right angle box. So we don't have a hypotenuse. So we know this should be a tangent formula. But my angle, remember tangent has to have the angle. X. I don't have an angle. But I do have the opposite, 25, and I do have the adjacent, 20. So when the angle is missing, and if you didn't watch that video from this past time, go back and watch it. When the angle is missing, it's a special setup, and you do inverse tangent. You hit that second on the calculator, second, and it comes up with a tangent, second tan, and it'll come up with a -1. You don't see that -1, it's not right. You can't type in the -1. You have to let the calculator pull it up. If you're trying to do it at home on your phone, good luck. You need a regular calculator. All right, 25, then divided by 20. And just hit equal, and you'll get your answer. Let me see what it would be. Second 10, 5 divided by 20. And you get 51.3. 51.3 degrees. That's how big angle X would be. All right. Then we got a proof. Okay. So some of us still have a lot of trouble with this. You always start with given, and that's all you're going to do is match up the right one. But there's going to be a whole bunch of choices to choose from. But don't just skip given and go on. You're not through. You got to go put this stuff on the drawing. This is actually the one I had on the test before. So it won't be this one in particular. It'll be one similar. It'll probably be still one from your notes or that worksheet that we did. So go back and look over all those proofs that you had. So AY bisects XZ. So this is being cut in half, bisected, right? So what does that mean? What's going to happen if that's being bisected? Then I'm going to get equal pieces here and here. It's bisected. Well, guess what the second step is? XY, I just marked that. YZ, I just marked it. Why did I mark it? That's what needs to go here for your second reason is why did I just mark those equal? What made me mark it? This was number one. What made number two happen? The word bisect. The bisect is what made me mark it. Made it cut in half. So definition of bisector. Or bisects. It doesn't matter. It'll be multiple choice. Okay? Matching or whatever. Multiple choice. Alright, so then XY equals 16. Well, we hadn't talked about 16. Let's go back up here and look. Uh-oh, look. It's in the given. There were actually two givens right here. So that's another given. Alright. And then here, I'm going to put, don't forget, put it on the drawing. Don't forget the drawing. XY is 16. Now, they're saying the other piece. You understand, hey, they match, so I'm going to move that over there. Well, that moving it over is called transitive property. They're already equal, so transitive just says they're already equal, so move that 16 over there and make it equal that 2. Everything's equal, equal, equal. Look at it. The pieces are equal. This one equals 16, so the other one has to equal 16. If you can line them up, XY equals YZ, then XY equals 16, this is equal to 16. It's already equal. When you can do that, then that's transitive property. Okay? Alright, next. Clean that up a little bit. XY, which is that piece, is equal to, or plus, YZ, that piece, equals xz, that's a new one, a whole thing. Two little pieces adding up to be a big piece, segment addition postulate. Okay, that's number 5. Get a little squished here. All right, now we're doing math. Look here, you just wrote an equation. So now it's going to be more like algebra instead of geometry. What's happening from 5 to 6? What changed? They replaced some numbers. What's replacement called? Substitution. Alright? What happened right here? From 6 to 7. They added stuff, addition property. Okay? And then finally, there's one little tricky one that we didn't talk a lot about, but it won't be this one on the test anyway. And that's when you flip it around. 32 was here, and now it's here. It's not reflexive. Reflexive is when it's the exact same thing on both sides. This is flipping two different things, but they still are matching. So when you flip it, it's called symmetric. But like I said, that's not the exact one that's going to be on the test anyway, so I know the one on the test won't have symmetric, but that's what it's called. And you can see that back in your notes, symmetric. Alright, now back to a little more triangle work. Find x. Now this is one that we have gone over in class about the exterior angle. This is exterior, and these two way over here are called the remotes. And the formula was the exterior is equal to the sum of the two remotes. So if you'll just remember that, you can plug in your algebra. 25x minus 30 equals 1r, which is 10x, and the other r is 5x. And there's your algebra to go work out. 25x minus 30, this makes 15x. Oh, right, 35. Oh, there. All right, over here, 15x. All right, two sides of the equation. You can move your x's. You can say minus 15x. Move it over here, you get 10x. You got 30. We're going to move it to the other side because that's a regular old number. So plus 30 and plus 30. We already moved the 15. It's gone. All right, and so 10x equals 30, so x is 3. And that's all I'm making you find is just the plain old x. Alright, number, whatever this is. Alright, so this is a Pythagorean theorem problem. Alright, it doesn't look like one, but it is. So x squared plus x squared equals 16 squared. We did one like this before, and you just put the x's together. X's can be put together. 1x squared plus 1x squared makes 2x squared. 16 is 256. The first thing, don't do your root first. Get rid of that big 2. Divide out 2. Divide out 2. X is going to be, make sure I'm doing it right. X squared, don't forget the squared, is 128. And now, final step, get rid of square by square rooting both sides. So, second x squared on the calculator. And on my calculators, it comes up looking like that. If you got a TI-30X, that's what it should look like. And you put in 128. Gives you 11.3. So that's x. Alright, find a little bit. You got one big long segment. You got to go find the missing parts. And you're given some information up here at the top, so don't ignore that. CD is congruent to EF. Well, CD has an X, so EF should also have an X. Okay? So we still need to find AB. Well, I don't know why I put AB on there. It's not going to be, I think it's X. It's supposed to be X. Find X. How much is the X going to be? So, we're going to go figure that out. Let's look. 12 is a span of 3 pieces. 1, 2, 3 things that add up to be 12. Segment addition postulate. X plus 6 plus X equals 12. So that's 2x plus a 6 equals 12. Move your 6, you get 6. So the x ends up being 3 when you work it out. So these are both 3, and you can put them on the drawing. So now, how long is CD? Is 3. How long is AF? Add up all the little pieces from A to F. Don't count the 12 twice, so just ignore that. 5 plus 4 is 9, 12. That'll be 17 plus 3, so it'll be 20 for the whole thing. No, that ain't right. Oh, should be 21. My bad. Okay, so 21 adds up 5, 4, 3, 6, 3. Okay. West. No question. You're not here. All right. Good luck.